Welcome to the deep dive. Today, we're going to be looking at something. You've been exploring the world of code LLMs and specifically OpenCoder. You sent over this really fascinating paper, and it got me curious.
Yeah, it's a pretty exciting development in the field. OpenCoder is not just a high-performing large language model for code, but it's also what the researchers are calling an open cookbook. They've made the whole process transparent, which is unusual.
Right. So it's like they're not just giving you the cakes, they're giving you the recipe and showing you exactly how they baked it. I mean, just looking at figure one from the paper, it's clear OpenCoder is surpassing other open source code LLMs.
Exactly. It's outperforming models where only the weights are released, and it's significantly ahead of those that are fully open, with data sets and all. This kind of openness is a big deal because it allows researchers to really dig into what makes these code LLMs tick.
Okay, so let's unpack this recipe. The paper dives into the data used to train this LLM, which they call refined code table 2, shows it's absolutely massive. 960 billion tokens pulled from GitHub and sources like the Stack V2. That's a ton of code for the model to learn from.
It is. But it's not just about throwing a mountain of code at the model. The researchers were incredibly focused on data quality as well. They actually developed over 130 code-specific rules for cleaning this data, which is a lot more involved than the usual text cleaning you see with general LLMs.
130 rules. That's intense. What kind of cleaning are we talking about here? Give me an example.
Well, in section 2.1.1, they talk about removing things like pure hexadecimal code. It doesn't really contribute much to the model's understanding of code logic. They also filtered out really short snippets that lack substance. And here's where it gets really interesting. They tackled things like copyright notices and code comments, and even personally identifiable information, replacing them with placeholders.
Makes sense. You wouldn't want the LLM accidentally spitting out someone's old password, right? But even after all that cleaning, you're still left with a huge data set. What about duplicates?
That's another fascinating aspect. They address duplicates with both exact and fuzzy deduplication. But here's the twist. They focused on file-level deduplication rather than repository level, and that's actually a key finding.
Wait, so deleting duplicate files works better than deleting entire repositories? That seems counterintuitive.
You'd think so. But as they explain, in section 6.1, repository level deduplication ended up removing a lot of near-identical files. File level, while seemingly more aggressive, actually kept more diversity in the dataset. They even trained two 1.5B LLMs to compare one with each deduplication method, and the file level approach consistently outperformed the other.
So in a way, deleting whole repositories throws the baby out with the bathwater. You lose some unique code snippets that could be valuable for training.
Exactly. And this finding really emphasizes the importance of considering diversity and not just blindly filtering for what seems like clean data.
So we've got a clean and diverse data set. What else did they do to make sure this refined code data was top-notch?
Well, remember how we talked about OpenCoder being able to handle not just code, but code-related concepts as well? That comes from the pre-training data, too.
You mean things like documentation and explanations of how the code works?
Precisely. As highlighted in section 2.1.2, they included code-related web data, things like Stack Overflow discussions documentation to give the LLM context. It's like how you might read documentation alongside code to understand what's going on.
Right. I'm always hopping back and forth between code and documentation when I'm trying to figure something out. It's like getting the full picture.
Exactly. It's about providing the LLM with that broader understanding. And to get a sense of the data quality, they used PCA to visualize it, as shown in Figure 3. The embeddings for refined code were more tightly clustered compared to other datasets, suggesting higher quality.
So it's like all the good code is forming a tight-knit group, while the other datasets are all over the place. But wait, there's more to this data preparation, right? The paper mentioned something called annealing.
You're right. Annealing is like a finishing school for the model, which they discuss in section 2.2. After that initial training with refined code, they further refine the model using even higher quality data. Think of it like going from reading general coding books to focusing on the best, most insightful textbooks.
So what makes this annealing data so special?
They used some clever sources. One was what they called an algorithmic corpus, essentially code snippets that are self-contained like little coding puzzles. It's perfect for honing the model's problem-solving skills.
I like that it's like giving the LLM a brain workout.
And then get this, they also created code textbooks. They used another LLM to explain code from the algorithmic corpus, almost like creating study guides. It's LLMs all the way down.
Whoa, an LLM teaching another LLM.
Yeah,
That's pretty meta.
it is. And those code textbooks, along with high-quality code snippets from GitHub, help push the model's performance even further.
Okay, so we've got this incredibly well-cleaned, diverse, and refined data set.
Yeah.
But how do you turn all that data into a functional code LLM? There's got to be more to it than just feeding it code, right?
Absolutely. That's where the training process comes in. And OpenCoder's training is particularly clever. It's actually a two-stage process. First, they pre-train a base model, as explained in Section 3, and then they fine-tune it using a technique called instruction tuning, which is discussed in Section 4.
2 stages. Okay, walk me through that. What's happening in each stage?
The first stage is all about laying the foundation. They take that massive refined code data set and train the model on it using a model architecture similar to the popular Llama model. The specific details are listed in Table 4. It's about giving the model a broad understanding of code syntax structure, common patterns, and all that good stuff.
Got it. It's like teaching the LLM the ABCs of coding.
Yeah.
But what about the second stage, the instruction tuning? What happens there?
Well, that's where things get really interesting. This is where they take that foundational knowledge and refine it for specific tasks. Remember those code textbooks we mentioned? They use those along with other carefully curated instruction data sets to teach the model how to do things like generate code, complete snippets, and even understand complex instructions.
So it's like taking that basic coding knowledge and showing the LLM how to apply it to different situations, like writing a poem or translating text.
Exactly.
Yeah.
And they use a two-stage approach for this instruction tuning, as well as they explain in Section 4.2. First, they focus on theoretical computer science concepts, algorithms, data structures, that kind of thing. It's about making sure the LLM understands the why behind the code, not just the how.
So it's not just about writing the code, but also about understanding the underlying principles. It's pretty cool.
It is. Then in the second stage of instruction tuning, they shift gears and focus on practical coding tasks using high-quality code from GitHub. It's about teaching the LLM how to write code that's actually usable in the real world.
It's like making sure the LLM not only knows grammar, but can also write a compelling story or a persuasive essay. It needs to know how to use those skills in a practical way.
That's a great analogy. And this two-stage instruction tuning seems to be a key factor in OpenCoder's success. It allows the LLM to be both a know-it-all, able to explain those complex concepts, and a doer capable of writing high-quality code. It's a really elegant approach.
Okay, so we've talked about the beta, the cleaning, the annealing, and the two-stage training process. But how do we know if this thing actually works? What were the results?
You're right, we need to talk about the results. And in this case, the results are measured through a series of rigorous benchmarks that OpenCoder was evaluated on, as mentioned in Section 5. These benchmarks test the model's ability to do everything from generating code from scratch to completing code snippets to understanding those complex coding concepts we talked about.
So it's like putting OpenCoder through a series of coding challenges to see how it performs.
Exactly. And guess what? OpenCoder passed with flying colors. They used several industry standard benchmarks, including Human Evil, MBPP, and Big Code Bench. Human Evil and MBPP are great for testing a model's problem-solving skills, while Big Code Bench focuses on how well it handles complex instructions and makes accurate function calls across different libraries.
So it's a good mix of testing both practical coding skills and the ability to work with real-world tools and libraries.
Precisely. And OpenCoder achieved state-of-the-art results in all of these benchmarks, even surpassing some proprietary models that aren't available to the public.
Wow, so it's not just open source, it's actually one of the best performing code LLMs out there. That's impressive.
It really is. And the results are even more remarkable when you consider that OpenCoder is fully reproducible. Anyone can take the code and data the researchers have released and recreate OpenCoder themselves. That level of transparency is crucial for building trust and ensuring the results are reliable.
That's amazing. So you're telling me that anyone with the right resources could build their own OpenCoder? That's pretty empowering.
It is. It opens up a lot of possibilities for researchers and developers.
Okay, all this is fascinating, but I have to ask, why go through all this trouble? What's the big deal about creating an open source, high-performing code LLM?
That's a great question. OpenCoder is a significant development because for a long time, the best code LLMs were locked away, developed by big tech companies and inaccessible to the wider research community.
It's kind of like a secret recipe that only a few people had access to.
Exactly. And that lack of transparency created a real barrier to progress in the field. Researchers couldn't fully understand how these models worked, and they couldn't build upon them to create even better ones.
It's like trying to bake a cake without knowing all the ingredients or how they interact.
Yeah.
You might get something that looks like a cake, but it won't be as good.
Right. OpenCoder changes all of that.
Right.
By releasing not only the model weights, but the entire training process, the data cleaning methods, even the training code, the creators have essentially democratized access to a top-tier code LLM.
It's like opening at the bakery and sharing the recipe with everyone. It's a real game changer.
Absolutely. Now, researchers worldwide can dive into OpenCoder, learn from it, and push the boundaries of what's possible with code LLMs.
That's incredible. And it allows developers to customize OpenCoder to fit their needs, creating specialized LLMs for specific coding tasks. It's like having a super versatile toolkit.
You got it. And that's
Yeah.
just the start. OpenCoder has the potential to be used in education to make learning to code more accessible, and even in assistive technologies to empower people with disabilities.
Wow, that's amazing. It's like breaking down barriers and making technology work for everyone.
Hmm.
But we're not done yet, are we? The paper also goes deeper into analyzing what makes OpenCoder so effective.
You're right. Their analysis is where it gets really interesting. They ran some fascinating experiments to understand what factors contribute most to OpenCoder's performance. Remember how we talked about the importance of data cleaning? They did some A/B testing comparing OpenCoder's performance with and without that code-specific.
What did they find?
The results are pretty clear, as shown in Figure 1. The models trained on the clean data were consistently better than those trained on the raw, unclean data. It really highlights the fact that data quality is just as important as data quantity when it comes to building a powerful code LLM.
You can't build a strong house on a shaky foundation. It makes sense that clean, high-quality data would lead to better results.
Exactly. And they also experimented with different deduplication techniques. Remember how we talked about the surprising finding that file-level deduplication was actually better?
Yeah, that was pretty counterintuitive.
Well, they wanted to understand why that was the case. So they compared file-level deduplication with repository-level and even chunk-level deduplication.
And file level still came out on top.
It did. Their analysis, discussed in Section 6.3, suggests it's because file-level deduplication, even though it seems like it removes more data, actually preserves more of that valuable diversity within the data set.
So it's not just about getting rid of duplicates. It's about maintaining that diversity, making sure the LLM is exposed to a wide range of coding styles and approaches.
Precisely. And that diversity is crucial for ensuring that the LLM can handle a wide range of coding tasks effectively.
We're back for the final part of our OpenCoder deep dive. And, we've talked a lot about OpenCoder's performance on these English language benchmarks like Human Evil and MBPP. But the world of code isn't just English, is it?
You're absolutely right. Code is a global language, and a truly powerful code. LM needs to understand and generate code in multiple languages. That's something the OpenCoder team really focused on.
Okay, so how did they approach this multilingual challenge? Did they just translate everything, or is there something more to it?
It's a lot more than just translation. They started with a multilingual data set. Remember FineCode, that massive pre-training data set we discussed? Well, Section 2.1.3 mentions that it includes code in a whopping 607 different programming languages.
607 languages. That's incredible. That's like a United Nations of code.
Yeah.
How do you even begin to train an LLM on that kind of linguistic diversity?
It's definitely a challenge, but the OpenCoder team was up to the task. They used a technique called multilingual modeling, where the LLM learns to recognize patterns and relationships that are common across different programming languages.
So instead of treating each language as a separate entity, it's more like learning the underlying structure, the grammar of coding that transcends specific vocabulary.
Exactly. And that's a really powerful approach because it allows the LLM to transfer knowledge from one language to another. For example, if the LLM learns how to write a loop in Python, it can apply that knowledge to writing a loop in Java or C++.
That's fascinating. It's like having a universal translator for code. But how do we know this multilingual approach actually works? Did they test it?
They did. They evaluated OpenCoder on several multilingual benchmarks, including MultiPLE and McEvil. MultiPLE, as explained in Section 5.2, takes coding problems from Human Evil and translates them into a bunch of different languages like C++, Java, JavaScript, and more. It's a really good way to test if an LLM can actually apply its coding skills to different syntaxes.
So it's like a multilingual coding exam. How did OpenCoder do?
It passed with flying colors. Table 8 shows that OpenCoder achieved state-of-the-art results on MultiPLE, surpassing other open-source code LLMs and even some proprietary models. And on McEvil, which covers an even broader range of programming languages, OpenCoder again demonstrated its impressive multilingual capabilities.
That's remarkable. It seems like OpenCoder is a true polyglot of the coding world. This multilingual proficiency opens up so many possibilities.
It does. Imagine using OpenCoder to translate code between languages or to create tools that help developers learn new programming languages faster. It could break down a lot of the language barriers that exist in the coding community.
That would be amazing. So much potential there. Okay, before we wrap up, I want to circle back to something we talked about earlier. The researchers behind OpenCoder were very intentional about making their work transparent and reproducible. Why was that such a priority for them?
That's a great question, and it speaks to the core values of the OpenCoder project. They believe that AI research should be open, accessible, and reproducible. They wanted to create a model that was not just powerful, but one that could be studied, understood, and built upon by others.
So it's not just about creating a great tool, it's about fostering a culture of openness and collaboration within AI research.
Exactly, and their commitment to transparency is evident throughout the project. They released all of their code data and even provided detailed documentation of their training process. It's like they're saying, here's everything we did, go ahead and see for yourself.
That's a big deal, especially in a field where secrecy and proprietary algorithms are often the norm.
Absolutely, it's a breath of fresh air. By making OpenCoder completely open source, they've created a platform for innovation and collaboration that has the potential to reshape the entire field of code LLMs.
This has been such an insightful deep dive into the world of open source code, LLMs. OpenCoder really stands out as a shining example of what can be achieved when researchers prioritize transparency and collaboration. What are your final takeaways for our listeners?
If you take away just one thing from this deep dive, let it be this. OpenCoder is not just a tool, it's a game changer. It has the potential to revolutionize how we write, understand, and interact with code. It demonstrates the power of open science and the incredible things that can happen when we work together towards a common goal.
I couldn't have said it better myself. So there you have it, everyone, our deep dive into OpenCoder. We've covered a lot of ground, but we've only just scratched the surface of what this incredible model is capable of. So go out there, explore OpenCoder, and see what amazing things you can build with it. And until next time, keep on diving.